Hey everyone, my name is Thiago Vasquez and this is my video explanation for insert sort. First of all, I want to mention that this is one of the most intuitive ways to sort a list, and it's the way that people usually think of when they have to sort a list manually. Very similar to selection sort. Of course, this is not one of the most efficient ways to sort a list, and it's not even close, but I'll talk more about that later. This algorithm follows three basic rules. Number one is that we work from left to right. Number two is that we examine each item and we compare two items on its left. And number three is that we insert the item on the correct position in the array. Let me give you an example. Unfortunately, I don't have a whiteboard with me, so I wrote the example on my notebook. And just to clarify, I colored the sorted partition of the array in blue. Okay, let's say we want to sort this array. Of course, we work from left to right, so we start with 2. There's nothing at the left of 2, so 2 is already sorted, right? We color it in blue. Now we look at 8. We compare 8 to its items on the left. So we compare 8 with 2. 8 is greater than 2, so we leave it on the same place, right? And 8 is already sorted. So now we look at 5 and compare it to its items on the left. 5 is less than 8, so we swap it with 8, right? Now 2, 5, and 8 are already sorted. Now we look at 3, right? So first we look at its item on the left. So we compare 3 with 8. 3 is less than 8, so we shift them positions, right? Now we compare 3 with its other item on the left, which is 5. 3 is also less than 5, so now we swap 5 and 3 again, and then we just insert 3. So now 2, 3, 5, 8 are sorted. We look at 9, we compare it to its item on the left. 9 is greater than 8, so we just leave it at the same place. And now we have to look at 4, the last item on our list. We compare it to its item on the left. Of course, 4 is less than 9, so we swap them. Now we compare it again. We compare 4 with 8. Of course, 4 is less than 8. So we swap them again. And then we compare 4 again with its item on the left. So we compare 4 with 5. 4, of course, is less than 5. So we swap them again. And now 4 is ready to be inserted on the array. So now we have a full sorted array. And yeah, it's as simple as that. As I said at the beginning of the video, this is one of the most intuitive sorting algorithms that there are. So I don't think it's really that hard to understand. I'll go over the same example one more time. Of course, a little quicker this time. So we have this initial array. Of course, 2 is at the left. There's nothing on the left, so 2 is already sorted. We look at 8. We compare with 2. 8 is greater than 2, so all right, 8 is already sorted. We look at 5. 5 is less than 8, so we swap them, and then these 3 are already sorted. Then we look at 3. 3 is less than 8, so we swap them. We don't insert 3 yet. We compare it to 5. We make sure that it's greater than 5. 3 is not greater than 5, so now we swap 3 and 5. And now, yeah, we have this space left, perfect, to insert 3. And of course, this 4 are sorted already. We have 9. 9 is not less than 8, so it's already sorted. And now we're just missing 4. We swap 4 and 9. Now we swap 4 and 8. Now we swap 4 and 5, and then we insert 4. And then we have our whole array sorted. What we're doing is basically looking at all our items on the left and stop once one of the items is less than our current item. And of course, we shift accordingly. Realistically, this isn't always helpful. Realistically, this is not always helpful. In fact, I don't think it's helpful on probably most cases. But in case that we need an easy algorithm to understand which is stable, well, we have this one. And of course, this is an algorithm that's easy to understand and everything can be perfect, so it has its drawbacks. Its main drawback is that, of course, like selection sort, it has a runtime of O(n) squared. However, another advantage of insert sort compared to like its brother or like the most comparable sorting algorithm, which is selection sort, is that unlike selection sort, the best case for this sorting algorithm is has a runtime of O of n, not O of n squared. And this happens when the array is already sorted. Because since our array is already sorted, we just have to look at our left one time for each element. So this is a pseudocode for insertion sort. I'm not gonna really explain how it works, since the point of this video is just explaining how the algorithm works, but you can definitely pause the video and take a look at it if you want. And finally, of course, since we are working in the same array, it's an algorithm that's in place. So the final takeaways of insertion sort. Number one, it's a very basic and intuitive algorithm, similarly to selection sort. Number two is that its worst and average runtimes are, of course, off and squared. And our best runtime, which is when the list or array is already sorted, is off n. Then, well, also we have an algorithm which is stable, which means it maintains duplicates in order as they come in the array. And finally, it's an in-place algorithm. So that's about it. I hope you liked my explanation and my two different soccer shirts, and I'm gonna end the video with a phrase that I like a lot. Computer scientists don't get paid for the amount of work they do, but rather for the amount of things they know.